So this video, we will show you another shift instruction, SHLD and SHRD. So this one you will see they are still the shift to the left instruction, but we add a destination. So this one will be a little different is, earlier our shift example, we only have two operands. So the first operand is your source operand and also is your destination operand. Then the second operand is immediate value or CL. That means how many bits you want to shift. But this SHLD and SHRD, they will do is you can provide a source operand. So this source operand is whenever you have the open up space for your destination operand. So then we will using the source operand to fill up. So now you will see since we try to shift to the left, right? So that's why you will go to the left. So your least significant bit, your lower bit will be open up. So that's why the bit position, if they are open up, before we only use the 0 to fill up. But now when you use the SHLD, the open up position, they will be shipped by the most significant bit of the source operand. So that's why whenever you have open up, the source operand will fill one by one. So the source operand is never being affected. It's just a value to refer to. And it has to be a register. So the syntax is like this. You have the shift to the L with the destination. You have destination operand. You have another one is source operand. So then your count actually is the third one. So that's your operand type. So one thing is we know here your register for your source, they have to be registered. And also your destination operand and the source operand, they need to be the same size. So if your destination is 2 bytes, you need to use the 2 byte register. So if your destination operand is 4 bytes, you need to use the 4 byte register. Destination operand can be either register or memory operand, but the source operand has to be registered. About the count is the same. They can either be immediate value or you need to use the CL. So we see the example how we really do the shift. So this example, we just say we will shift AL. We will update AL value, but we're using the BL is the source operand. We just shift for 1 bit first. So since you want to shift to the L, right? So you see you will open up to the left. So usually what I will do is I write destination operand here. So then my source operand I put on the right. So when you do the shift to the left, still the same. You see you still have your most significant bit to the carry flag. So each one I move one by one to the left. So then you will see I have one open up, right? Right, before when you use the SHL only, this open up, we will fill up with the 0. But now when we do the shift destination, shift D, so then the open up value, we will fill up with the source operand. So that's why the source operand, the most significant bit will come here. So you can shift 1 bit, but also right, you can shift more bits. So for example, we see here, when you want to shift the W val, so we have 1 W val, that's the word 2 byte. I want to shift 4 bits to the left. So then we will replace the lower 4 bits with the high 4 bits for AX. So that means your destination operand is W val, that can be a memory operand. But your source operand has to be a register. So we just say, for example, our W val is the word. So then 2 bytes we're using in hex. So this one we on purpose to show you in the hexadecimal because this 4-bit. So here, when we do the, just say for example, AX value is like that, your WVAL value is like this. So when you do the shift left, right? So that's your source operand. That's your that's your destination operand. That's your source operand. We shift to 4-bit. So since I shift to the left, right? So I usually have the destination put here. So I go left. So you go left for 4-bit. So every 4-bit binary is 1-digit hex. So that's why 9 is to the left, it's gone. So B2 forward, A2 forward, 6 forward. So this one open up, we're using the AX to fill it up. So this one is SHLD. So on the other hand, mean you shift to the left with the source value. So the same thing you can guess, we have SHRD. So SHRD will be very similar, but we shift to the right. So when you try to shift to the right, so that's why your most significant bit open up. So when you shift a destination operand given number of the bits to the right, so the bit position open up, they will be shift filled by the least significant bit of the source operand. So later I will show you why they will go the other way. The reason is because we go to the right. So that's why the source operand we're using the right one to move over. So the same thing, your syntax still have 3 operands. Your destination operand can be memory operand, can be registered, but the source has to be registered. And the source operand and the destination operand, their size should be the same. So the count can be either immediate value or we can use the CL. So we see how we will shift to the right. So we just see the same thing. For example, our destination operand is AL for 1 byte. Our source operand is 1 byte. But since we shift to the right, so usually shift to the right, I will have my destination operand I put on the right hand side because I need to shift to the right. So that's why you can see when I shift to the right is the least significant bit we'll do first. I move to C carry flag. So each one I move. So this one, my most significant bit open up. So when I open up, actually the source, you're just using the least significant bit to move on to copy over to the open up value. So that's the SHRD. So SHRD, the same thing we can using the 4-bit to show in the hex value. So if you want to shift AX 4-bit to the right, so you place that highest 4-bit with the lowest 4-bit with the DX. Basically, you are talking about is your destination operand is AX, your source operand is DX. So we just say, for example, they all look like this. So whenever you want to do the shift to the right, so I have my destination operand I will put on the right hand side. So when I see shift, it will be easier. Since I shift to the right, B 4-bit, again, 4 bits in binary mean 1 digit in the hex. So B is gone. 4 to here, 3 to here, 2 to here. So the open up 4 bits, we were using the least significant bit from the DX to move here. So 4 is here. So then afterward, your DX, your AX being changed, your destination operand value being changed, but your source operand don't change. So that's SHRD and SHLD. So in the video, I won't go over the example for your practice example. But remember, just like in your handout file, we do have the your turn practice question. So those practice questions, you have the question, you have the answer. Please make sure you will practice on that to understand, to make sure you understand what we talk about in the video. So then our lab exercise, we will use the SHLD and SHRD, for example, to do your lab exercise. So that will be in the next video.